Welcome back everyone to our final session. Session 8, Debugging, Visual Testing, and Best Practices. We've covered an enormous amount of ground together over the last 7 sessions, from installing Playwright for the very first time, all the way through building out a full framework with page objects, fixtures, API testing, and a real CI pipeline. Today, we round all of that out. We're going deeper on debugging than we went back in session 1. We're adding visual regression testing to our toolkit, and then we're going to step back and look at the whole framework as one complete picture before we wrap up with your team's actual roadmap going forward. Quick recap of session 7. Cross-browser and mobile projects, workers and sharding, retries and timeouts, reporters, and CI/CD with GitHub Actions. Today's agenda, 6 things. A deeper dive into the trace viewer, plus page.pause and the VS Code extension. Visual regression testing with toHaveScreenshot. A checklist for root-causing flaky tests. A code review checklist and the full anti-patterns recap from across the whole series. The complete framework architecture laid out end to end. And finally, a course recap and your team's actual roadmap conversation. Let's start with the trace viewer, because back in session 1, we only really scratched the surface. Here's what experienced teams actually use it for, day to day. 3 things worth knowing: the network tab, inspect every single request and response for that exact test run. Headers, timing, payloads, all of it. Timeline scrubbing, drag through the action timeline to see exactly what the DOM looked like at any single point in time during that run. And the source tab, jump straight from a failed action to the exact line of your test code that actually caused it, with 0 manual searching required. Let's talk about page.pause, which is genuinely one of the most useful tools for interactive debugging and one that doesn't get used enough. Here's the code: await page.goto/checkout. Then await page.pause, and execution just halts right there, opening the inspector. 3 things this gives you. It drops you into the live Playwright inspector mid-test in headed mode so you can actually see exactly where things stand. You can use the locator picker to try out selectors against the real current state of the page, not a guess, the actual live DOM. And you can step forward one action at a time or just resume the test and let it finish running normally. This is honestly one of the fastest ways to answer, wait, what does the page actually look like right now, in the middle of writing a new test? Let's talk about debugging, right where you actually write your code, inside VS Code itself. 4 things the extension gives you: run or debug directly from the gutter, click the green arrow next to any test to run it, or the debug icon to step through it with real breakpoints. Pick locators visually. The extension's locator picker highlights elements on the live page as you hover over them. Watch mode, it automatically reruns affected tests as you save changes to either your test files or your source files. And inline trace viewing, open a failed test trace directly from the Test Explorer sidebar with no command line needed at all. If you haven't installed this extension yet, genuinely stop and do it today. It changes your day-to-day workflow more than almost anything else we've covered. Let's move into visual regression testing. toHaveScreenshot compares a rendered page or a specific element against a saved baseline image, pixel by pixel. Here's the code: await expect page dot to have screenshot dashboard.png. 2 reasons this matters. It catches what functional tests genuinely miss: a button that's technically still clickable but visually broken, overlapping something else, or the wrong color entirely, still fails a visual test even though every functional assertion would pass cleanly. And it works on individual elements too. Expect locator dot to have screenshot checks just one component, not the entire page, which is useful when you only care about one specific piece of the UI. Let's see this in actual code. Test, dashboard looks right, async, page, navigate to slash dashboard, then await expect page, dot to have screenshot, dashboard dot png with an option called max diff pixel ratio set to 0.02. Here's how this actually works in practice. The very first run creates the baseline image for you. Every run after that compares against it, and a difference beyond your tolerance fails the test and saves an actual visual diff image so you can see exactly what changed. Here's a problem you'll hit almost immediately with visual testing. Timestamps, ads, avatars, live counters. These would fail every single comparison, every single run if you don't handle them. Here's the fix. Await expect page dot to have screenshot dashboard.png with a mask array containing the last updated element and the avatar element, and a mask color of a bright magenta. Two things worth knowing. Masked regions get painted a solid color before the actual comparison happens. Their content never affects the diff at all, no matter what it actually says. And as an alternative approach, specifically for animations, you can freeze them using page.emulateMedia with reduced motion set to reduce. At some point, your UI is going to change on purpose and your baselines need to catch up. Here's how. npx playwright test dash dash update dash snapshots. Three things worth knowing here. This regenerates every single baseline image to match the current UI. Always review the actual diffs before you commit them. Don't just blindly accept everything. Baselines are OS specific by default, so generate them inside CI or Docker specifically to make sure they actually match your CI's rendering environment, and commit updated baselines in the exact same pull request as the intentional UI change that caused them, so reviewers can see both the code change and the visual change together side by side. A brief overview of something adjacent. Component testing. Playwright can also mount and test individual UI components in complete isolation. React, Vue, and Svelte are all supported, without needing a full running application or backend at all. Here's a quick example. Import test and expect from the experimental component testing package, import a button component, then mount it with a label prop of save and assert that the rendered component actually contains the text save. The distinction worth remembering. End-to-end tests verify real user flows start to finish. Component tests verify one component's behavior in complete isolation, faster and more granular. Different tool for genuinely different job. Let's talk about a systematic approach to flakiness, because just retry it is not actually a strategy. 5 steps. Open the trace from the failed run. What does the timeline actually show you happened? Is it timing? Look for a missing wait or auto wait racing against a genuinely slow network response. Is it state? Check for shared fixtures, tests depending on execution order or leftover data from a previous test. Is it the environment? Compare local against CI, looking specifically at viewport size, time zone, or local differences. And finally, reproduce it locally using dash repeat each equals 10 before you ever declare it actually fixed. Let's talk about what to actually look for before approving a pull request that touches tests. Uses semantic locators, get payroll first, not brittle CSS or XPath. No hard-coded wait for timeout, real waits or web first assertions only. No test dot only or dot skip left sitting in committed code. Tests are independent, no shared mutable state, and no dependence on execution order. Assertions live in the test itself, not tucked away inside page objects. And new flows are tagged appropriately with @smoke or @regression as makes sense. print this one out, honestly. Pin it up. This is the actual practical distillation of everything we have covered across all 8 sessions. Let's pull together the greatest hits of anti-patterns from across the entire series, all in one place. Hard-coded waits instead of web-first assertions, brittle CSS or XPath chains instead of semantic locators, shared mutable state causing order-dependent flaky tests, committed test dot only or dot skip, silently disabling coverage without anyone noticing, assertions inside page objects instead of living in the test itself, and retries used to mask real bugs instead of actually diagnosing the root cause. If you avoid just these 6 things consistently, you are genuinely ahead of the vast majority of test suites out there in the wild. Let's talk about keeping your suite healthy for the long term, not just on day one. Review flaky tagged tests regularly. A quarantine tag isn't a place to forget about something forever. Schedule real time to actually fix or delete them. Watch your suite's total runtime. Growing slowly over time is completely fine. Growing fast means it's genuinely time to shard or to trim redundant coverage somewhere. Keep the page object layer current. Delete page objects for features that have been removed, because stale classes rot and quietly confuse new contributors joining the project. And revisit your code review checklist periodically. Standards drift naturally over time, and a recurring team conversation is what keeps everyone genuinely aligned. Let's zoom all the way out and look at the complete picture from top to bottom. CI/CD, GitHub Actions sharded, running across multiple browsers with reports uploaded automatically. Config, playwright.config.ts, holding your project's retries, reporters, and environment settings. Fixtures, test.extend, providing page objects, tokens, and storage state automatically to your tests. Page objects, locators, and actions with one class per page or component. And tests describe blocks and hooks, web-first assertions, tags, and a genuine mix of API and UI coverage working together. That's the entire framework, 5 layers, and you've now personally built every single one of them yourselves across these 8 sessions. Let's actually walk back through the whole journey together one more time. Session 1, Foundations and Environment Setup. Session 2, Locators and Basic Interactions. Session 3, Assertions, Test Structure and Hooks. Session 4, Advanced UI Interactions. Session 5, Page Object Model and Fixtures. Session 6, API Testing and Network Control. Session 7, Cross-Browser, Parallelization, and CI/CD. And Session 8, right here, right now, Debugging, Visual Testing, and Best Practices. Take a second and actually look back at Session 1 in your head. That's a real distance you've covered. Let's bring it all together with one final capstone exercise. 5 things. 1. Pick a real flow in your own application and add a visual regression test to it with a masked dynamic region. 2. Deliberately introduce a flaky test and then use today's root-causing checklist to actually diagnose it properly. 3. Run the code review checklist against a real existing pull request, yours or a teammate's. 4. Sketch out your own team's version of the framework architecture diagram we just looked at. 5. Write down 3 concrete next steps for your team's actual Playwright adoption going forward. That last one matters more than any of the code. Take it seriously. Let's actually talk as a team for a bit. A few real prompts to get us going. What existing test suite, if you have one already, needs migrating over to this structure? Who's going to own the page object and fixtures layer going forward? What's our actual split between @smoke and @regression tests? And where does each of those run? And honestly, What's actually blocking us from adopting this today? I want to genuinely spend real time on these because a framework only pays off once it's actually adopted by the team, not just understood in a training session. Before we close out, a few places to keep learning after today. Playwright.dev/docs, the official documentation. It's consistently excellent, and it should be your source of truth over any blog post or tutorial you find, including this one. The Playwright GitHub repository browse real-world test examples directly in the project's own test suite, which is honestly a great way to see idiomatic patterns in action. The Playwright Discord, a genuinely active community, great for fast answers on edge cases you run into. And this deck series itself, revisit any session's slides as a refresher whenever you actually need one. That's exactly what they're here for. That's the series. All 8 sessions, from an empty folder to a complete production-ready framework. I want to genuinely thank you all for sticking with this through all 8 sessions. That's a real investment of time, and it shows. You now know how Playwright is architected, how to find and interact with anything on a page, how to structure tests that are actually maintainable, how to test both the UI and the API together, how to run everything at scale in CI, and how to debug and visually verify all of it when something goes wrong. Now go write some reliable tests. Thank you, everyone.